Hey, welcome to our homework help video over 8-18 oxidation numbers and oxidation reduction or redox reactions. Let's start with number one. What's the oxidation state of phosphorus and tetraphosphorus decoxide? Tetra means 4, P4, dec means 10, O is 10. And they want to know the oxidation state or oxidation number of phosphorus. So before we begin assigning oxidation numbers, we have to remember that whichever element has the highest electronegativity automatically gets its oxidation number first. So if you look on your electronegativity table, which was part of your 8-17 notes, you'll see that oxygen is 3.5, phosphorus is 2.1. So oxygen almost always gets its oxidation number unless it's with fluorine, who's 4.0, the only element stronger, or unless it's with another oxygen, or in the peroxide ion. So oxygen gets its -2. We have 10 oxygens, so the total negative oxidation state is -20. It's written down here on the bottom, -20. Most often I write it here at the top, -20. Which means the total positive must be +20. The total oxidation positive is +20 because they must equal each other because tetraphosphorus decoxide is a neutral compound. So if the phosphoruses must add up to 20 and there's 4 phosphoruses, 20 divided by 4, each phosphorus must have an oxidation number of 5. 20 divided by 4 is 5. So the oxidation state or number of phosphorus is 5. Which means if we wanted to name P4O10 using the stock system, we could call it phosphorus 5 oxide. Question number 2, what is the oxidation or what is the stock name for dinitrogen trioxide? Dinitrogen is N2, tri would be O3. Oxygen again gets its oxidation number. It's the second highest at 3,5. Nitrogen's 3,0, so the oxygen gets its -2. We need to find out the total negative. There are 3 oxygens. -2 times 3 is -6. I usually write the -6 up here, but it's okay to write it here on the bottom. If the total oxidation or negative oxidation is -6, the total positive has to be +6. So the total oxidation positives +6, there are 2 nitrogens adding up to that +6, so each nitrogen must have an oxidation number of +3. Note again, when we're writing oxidation numbers, it goes sign followed by number. If it's an actual charge, you would write number followed by the sign. So anyway, nitrogen's +3 here, so the stock name would be nitrogen 3 oxide. Number 3, what is the oxidation state of sulfur in the thiosulfate ion? Oh, this brings back memories when you learned all your polys. The thiosulfate ion is S2O3. Its total charge is 2-. That means the oxidation numbers of the sulfurs and the oxygens, their totals must also add up to 2-. Sulfur is a 2,5. Oxygen is a 3,5. So oxygen again gets its number, -2. There's 3 oxygens, so the total negative oxygen state is -6. Our total must add up to -2 because the actual charge is 2-. The total oxidation of the atoms must add up to the charge when it has a charge, -2. So what do I add to -6 to get -2? The answer is +4. The sulfurs must add up to +4. The total +4. We have 2 sulfurs adding up to +4, so each sulfur must be +2. Number 4, carbonyl fluoride has the formula COF2, and they're wanting to know the oxidation state of carbon. So we begin assigning based on who has the highest electronegativity first. In COF2, without a question, fluorine gets its charge. It has the highest electronegativity of all. It gets its -1. So we write the -1 there. There are 2 fluorines, so the total contribution is -2. The second highest oxidation is oxygen, who's 3,5, because carbon's only a 2,5, so it's not going to get the number it wants. Oxygen does get its -2. So we have 2 fluorines at 1-, adding up to -2. We have 1 oxygen at -2, so the total minus is -4, which means the total plus must be +4 because there is no charge on the COF2. It is a molecular compound. It is not an ionic compound. So the carbon must add up to +4. There's only 1 carbon, so it's +4. On this compound, on this molecular compound, we would not try to name it in the stock system. The stock system's reserved for binary molecular or binary ionic. So its name is carbonyl fluoride. Number 5, potassium bromate. What are the oxidation numbers for the potassium and for the bromine in potassium bromate? The bromate ion is BrO3. It is 1-. Potassium's 1+. So we crisscross the 1 from the potassium and the 1 from the bromate ion. The formula of potassium bromate is KBrO3. Now they're wanting to know the charges of the potassium and the bromine in potassium bromate. So we're going to begin to assign numbers here. Oxygen has the highest electronegativity of all of these. Bromine, I think, is 2,8. Oxygen's 3,5. So oxygen's going to get its negative, -2. We have 3 oxygens at -2, so the total minus is 6. Potassium, if you remember in your rules, automatically gets +1. The alkali metals automatically get +1. The alkaline earths automatically get +2. So the potassium's +1. The oxygens are -6. So +1 and -6 is -5. The total charge of KBrO3 is neutral at 0. Although the bromate is 1- and the potassium is 1+, they have actual charges. Overall, the compound is 0. That means the bromine must be +5, because +1 and +5 is +6, -6 is 0. So the bromine is +5, the potassium's +1, and our answer would be E. Number 6 is a relatively easy one. If you remember, they're asking for the oxidation state of oxygen in ozone, O3. There's only one element here. It's oxygen. When you have a substance that's obviously not a compound, when you have a substance made up of only one element, that element's oxidation number must be 0 because you cannot hog electrons from another element of the exact same type. Let's turn to the back. Let's turn to the back. Here we go. That's not the back. Let's turn to the back. Hey, there's the back. How about that? Here we have a reaction of silver with H2S and O2. And we're making 2 new compounds. This reaction is not going to fit any of the reaction types we have. We have element, compound, element producing compound, compound. This is not any of our other 6 types. This is definitely an oxidation reduction reaction. Oxidation reduction reactions are easy to pinpoint, especially one like this, because we have an element and another element, and on the right side there are no elements, there is only compounds. If you remember, the oxidation numbers of elements are always 0. And now we have compounds over here, so they can't be 0 anymore. So oxidation numbers have changed for both the silver and the oxygen. Let's see what happens to silver. When silver's by itself, it's a 0. Over here, the silver's now with the sulfide ion. The sulfide ion's 2-. So that means the silvers must add up to +2. The sulfur is 2-, its oxidation number is -2. So the silvers must be +1. We have to have 2 silvers adding up to +2. That means each of them is +1. +2 divided by 2 is +1. So silver's gone from 0 up to +1. Its number has increased. It's because it's lost electrons. Here the silver has its electron. Over here the silvers have lost their electron to sulfur, as sulfur became the sulfide ion. So the silvers went from 0 up to 1. Oxidation is loss of electrons. Oil rig. Oxidation is loss of electrons. So the silver was oxidized. Question 7. What was oxidized? Letter A. Silver was. The substance that gets oxidized, whatever compound, or in this case, whatever element the substance that's oxidized was in, is called the reducing agent, because in order to be oxidized, you have to reduce something else. So silver is the reducing agent. Number 10, they're asking what's the reducing agent? It's silver, letter A. What happened to oxygen here? Well, oxygen's all by itself. Oxygen's all by itself, so its oxidation number is 0. Over here, it is now with the hydrogens. Oxygen's going to get its oxidation number of -2. It's the second strongest at 3,5. Hydrogen always has a positive oxidation number when it's with other nonmetals, except for ones nonmetals that it's stronger than, such as boron, silicon, and a few of the other ones. So the oxygen goes from 0 up to the number it wants to be, which is -2. Or down to the number it wants to be, which is -2. So oxygen goes from 0 down to -2. That number is reduced. 0 down to -2 is a reduction in the number. In oil rig, rig stands for reduction is gain in electrons. So oxygen here is not having a chance to hog any electrons. Over here, the oxygen's able to hog the 2 electrons, 1 from each of the hydrogens. So in this case, rig, oxygen is a gain in control of electrons. Oxygen was reduced, 0 down to -2. The substance that gets reduced must have oxidized something else. In this case, the silver was oxidized. So oxygen is serving as the oxidizing agent, which is where the term oxidizing agent gets its word from. Oxygen's reduced, it is the oxidizing agent. Hopefully we have a better understanding of what is going on here, and we will conclude the video.